Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson, I will explain the proof of the compound angle for cos A plus B. We will also be expanding the formula and we will do some examples. This is lesson 3 of 5. Have you subscribed yet? You can also visit my website onlinemaths.co.za. The link is in the comments below. There you will find all the chapters in the syllabus. Let's start with the maths. Now the compound angle cos alpha plus beta you will find on the formula sheet, and you will see it's very similar to the mother cos alpha minus beta. So this one cos alpha plus beta, it's the pattern cos alpha cos beta, and then because there's a plus inside the bracket, now there's a minus, and then sin alpha sin beta. We need to know the proof of this compound angle cos alpha plus beta, or cos A plus B. Now all we have so far is the previous one, the cos A minus B, which is cos A cos B plus sin A sin B. Now where we start is, on the left, the one we want is cos A plus B. So what you do is you are going to rewrite A plus B as A minus bracket minus B. So now you haven't changed the sum because a minus times a minus is a plus. So what you did was you wrote this A plus B so that it looks like the one that's familiar, A minus B. Now that it's familiar, you can expand cos A minus minus B into cos A cos minus B plus sin A sin minus B. Can you see? It's this rule. When there's a minus there, then there's a plus in the middle. And the angle is A minus B, A minus B. And then in the next step, you can say the cos of a negative angle is cos of the positive angle. And then what happened here? The sin of a negative angle is negative the sin of the positive angle. Therefore, cos A plus B is equal to cos A cos B minus sin A sin B. So what you did was you wrote A plus B as A minus bracket minus B, and then you used the rule you've got, the cos A minus B's rule. Expand each of the following using the compound angle formula. So all we've got so far is, and I gave it to you there in the blue, cos alpha plus beta is cos alpha cos beta minus sin alpha sin beta. So the first sum there, cos D plus E, you will write as cos cos sin sin. And then the angles are D and E. So you write D, E, D, E. And because this is a plus, this is going to be a minus. The next one, cos B plus 30. So the compound angle you write cos cos, sin sin. The angles are B and 30. Then you write B 30 degrees, B 30 degrees, and because this is a minus, that's a plus, this is a minus. The next one, cos 2x plus 60 degrees. The pattern, cos cos, sin sin. The angles are 2x and 60. So you write 2x and 60, 2x and 60. And because this is a plus, this is a minus. And then the next one, cos x plus y, the compound angle, the pattern, cos cos, sin sin. The angles are x and y. Therefore, it's x, y, x, y. Since this is a plus, this is a minus. Let's simplify. So now I give you the expanded rule and I want you to simplify. So let's spot the pattern first. Cos, cos, sin, sin. And the angles have to be the same. AB, AB. So that one as a compound angle is then cos A plus B. Remember, when this is a negative, this is a positive. The next one. Cos 3x, cos 5x. So the pattern, cos, cos, sin, sin. Angles have to be the same. 3x, 5x, 3x, 5x. So we can write this one as the compound angle cos 3x plus 5x. When this is a minus, this is a plus. The next one, let's spot the pattern. Cos, cos, sin, sin. And then the angle. Y minus 45 degrees. Y minus 45 degrees. So the pattern is there. Therefore, the compound angle is cos. And then your angles are y. And then the other angle was y minus 45 degrees. And remember, when this is a minus inside your compound angle, that's a plus. The next one, let's spot the pattern. Cos, cos, sin, sin. And then let's check the angles. 70, 10, 70, 10. Yes, it's the compound angle cos 70 plus 10 degrees. Remember, when this is a minus, that one is a plus. And then the last one, let's spot the pattern. Cos, cos, sin, sin. And then the angles, A plus B and a theta, and A plus B and a theta. So the compound angle is cos, and the angles A plus B and a theta. And remember, when this is a minus, this is a plus. The question is, evaluate cos 75 without using a calculator. Now, we've got special angles, but we don't have a special angle for 75. So what's going to happen is we are going to use our new knowledge of compound angles, and we're going to write the 75 as a compound angle for cos. 75 is the same as cos 45 plus 30. So can you see you are using your grade 11 grade 11 special angles in conjunction with your grade 12 compound angle. Now that one is your new angle. On the formula sheet, the compound angle for cos alpha plus beta. So we can write that one as cos 45 cos 30 minus sin 45 sin 30. And then cos 45 is root 2 over 2. And remember, although the question says without a calculator, nobody will know. As long as there's no decimals, root 2 over 2 is the answer. Cos 30, root 3 over 2 minus root 2 over 2 for sin 45, and sin 30 is a half. And then on the numerator, you can say root 2 times root 3 is root 6 over 4 minus root 2 over 4, and you can write it as one thing, root 6 minus root 2 over 4. We need to prove that cos 5b plus cos b is equal to 2 cos 3b cos 2b. Now remember, when we prove an equation, we always split it up in left-hand side, right-hand side. Now for the left-hand side, there's a 5b and a b. And on the right-hand side, there's a 3b and a 2b. So our job is to write the 5b and the b in terms of whatever we found on the right-hand side, a 3b and a 2b. So do you agree? 5b is the same as 3b plus 2b. So I wrote the 5b as a compound angle for cos. And then the cos b I can also write in terms of 3b and 2b. We can say that 3b minus 2b is just b. Then we've got our compound angles on the formula sheet for cos alpha plus beta. So the compound angle for cos 3b plus 2b we can then write as cos 3b cos 2b minus sin 3b sin 2b from the formula sheet. Remember, when this is a plus, this is a minus. And then this one, the cos 3b minus 2b, that was the previous lesson. Cos alpha minus b. From the formula sheet, we can write that one as cos 3b cos 2b plus sin 3b sin 2b. Then minus sin 3b sin 2b plus sin 3b sin 2b, they can cancel each other out. And I'm left with cos 3b cos 2b plus another cos 3b cos 2b, and the answer 2 cos 3b cos 2b, and that is what the right hand side is. If sin 32 is equal to k, express the following in terms of k. Now this is a very, very important sum. When you want to tackle this sum, my advice to you is we start with making a help sketch. Now the help sketch on the right hand side there consists of a right angle triangle in the first quadrant with the angle that's given, the sin 32, in standard position. And then you always work out the other angle. In this case, it's going to be 58, since angles of a triangle add up to 180. And then we're going to add all the sides. Now, what was given was sin 32 is equal to k. And then if there's nothing, it's the same as k over 1. And then sin's ratio is y over r. So we know that y's value is k and r's value is 1. And then we work out x, the missing side. And we're going to work out the missing side with the theorem of Pythagoras. X squared plus y squared is r squared. And then we make x squared the subject of the formula, and we substitute in r's place 1 squared, and then in y's place k minus k squared. And then we don't want x squared, we only want x. Therefore, we take the square root. And then x's value is root 1 minus k squared. And you fill it in on your sketch. So now your help sketch has all the angles and all the sides. Now we can go back to the sum. So the sum was cos 58 degrees in terms of k. And because I made you work out all the angles, now you can see the relevance of 58, because cos 58 is exactly the same as sin 32. That's a cofunction. And then sin 32 was given that it's k over 1. Number B, cos 62 degrees. Now there's no mentioning of a 62 degrees. The angles in question are 32 and 58 degrees. So it's your job to see that you can now write 62 in terms of a compound angle for cos. And it's going to be cos 30 plus 32. And where does the 30 fit in? It comes from your special angles. So now you've got a compound angle. On the formula sheet, you find cos alpha plus beta. So therefore, you can expand that one into cos 30 cos 32 minus sin 30 sin 32. And now the value for cos 30 is root 3 over 2. Cos 32, you can say, if you go to your help sketch, let me show you. Cos this ratio is x over r. That's why it's root 1 minus k squared for x and r's value is 1. Minus sin 30 is a half and sin 32 was given that it's k over 1. And then you can just complete your sum by multiplying in this 3 into the root and the answer. Root 3 minus 3k squared minus k over 2. We need to prove that cos 70 cos 10 plus cos 80 cos 20 is equal to a half. Again, when we prove, we split our sum into left hand side, right hand side. Now the first thing we do is we check the pattern. Cos, cos, and then we find cos, cos again. We were expecting sin, sin there to use the compound angle. But we've got something we call cofunctions. And then cos 80's cofunction is sin 10. And cos 20's cofunction is sin 70. Therefore, in the place of cos 80, we can write sin 10, and in the place of cos 20, we can write sin 70. And can you see the compound angle now? Cos, cos, sin, sin. So we check the pattern, but we also have to check the angles. 70 degrees, 10, 10, 70. So that's the problem. They're not in the same order. So we can swap these two around because there's a multiplication in between. So then we end with cos 70 cos 10 plus sin 70 sin 10. Can you see it's the compound angle for cos alpha minus beta? Since this is a plus, then that's going to be a minus. So we can reduce this one to cos 70 degrees minus 10, which is cos 60 degrees, and cos 60 degrees is a half. Therefore, the left hand side is equal to the right hand side. In the next lesson, I will explain the compound angle for sin A plus or minus B. Click on the video in the left hand corner to take you straight to that lesson.